This video is for my 7th grade math class and is over lesson 25, dividing fractions. So before we get to dividing fractions, we're going to take a look at some division just in general and what does it mean. So here on our paper you see a box, a rectangle, that if I've done my measurements correctly, it should be about 6 inches long. And so I'm asking how many 2's are in 6. And so you see these boxes here that are about 2 inches long. So how many 2's are in 6? We're asking 6 divided by 2. So 6 divided up into 2-inch segments equals how many 2-inch boxes. So how many 2-inch boxes would this be? Well, you can see from the diagram 1, 2, 3 of these boxes is the full 6. Up here, or excuse me, down here, we're asking now how many 2's are in 7. So this big long green box is now 7 long. So we're asking 7 divided by 2. Well, 1, 2, 3 of them fit in here. But then this last guy, only half of him fits in. So we have 1, 2, 3, and then a half 2's that fit into 7. So my answer is 3.5, which matches what we know, that 2 goes into 7 3 times with 1 piece out of 2 left over. Now if we apply this to fractions, we can see the same idea happening here. So if I say how many 1/4 are in 1, this really ends up being 1 divided by 1/4. How many 1/4 are in 1? So I've taken a green segment that's about 1 inch long and then about a 1/4 inch segments down here. And we'll see that it takes 1, 2, 3, 4 of those. Now, I'm going to draw your attention to 4 as a fraction would be 4 over 1. And if you ponder that a little bit, you may see a connection here in just a moment. Now, over here, if we break this apart, how many 2/3 are in 1 though? So 1 divided by 2/3. So my green box is about 1 inch long. Each of these blue boxes is about 2/3 of an inch long. We see we've got a 2/3, but then only half of that 2/3. So we have 1.5 here. 1.5 though, if I think about turning this back into an improper fraction, 1 times 2 is 2 plus 1 is 3. This is really 3/2. And so, ladies and gentlemen, what we see here is that when we take 1 divided by a fraction, we end up getting the reciprocal of that fraction. So 1 over 4, if we flip it over, is 4 over 1. That's why the answer is 4. 1 divided by 2/3, well, 2/3, flip it over, we get 3/2, which is 1.5. So, ladies and gentlemen, down here, if I ask you how many 1/4 are in 5, you could measure this out and make a diagram, or we could take advantage of what we just discovered. We know that there will be the reciprocal. If this was 1, it would be the reciprocal of 1/4. Well, here's 1 right here. There's another 1, there's another 1, there's another 1. But we've got basically 5 is 5 1's put together. So however many there are 1/4 that fit into 1, there'd be 5 times as many that fit into 5. So 5 times the reciprocal here would then tell me that there are 20 1/4 that fit into 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Sure enough, that worked out just right. If we try to apply it down here then, 5 divided by 2/3, so how many 2/3 are in 5? Well, if there's 1 1/2 or 3 halves in each one, then there are 5 times as many in 5. So 5 times as many as 5, or as 3 halves. Well, if we change 5 into a fraction, that would just be 5 over 1 times 3 over 2. And so 5 times 3 is 15. 1 times 2 is 2. 2 goes into 15 7 times with 1 left over, and we have a denominator of 2. So let's see if this actually works out. We've got 1, 2, 3, 4, 5, 6, 7, and then half of that guy. So sure enough, it does come out as 7 1/2 of the 2/3. So ladies and gentlemen, if we put what we've discovered here together, we find this rule right here, that dividing by a number is the same as multiplying by its reciprocal. So if I have a over b divided by c over d, well, dividing by a fraction is the same as, there's my blue there, this fraction. Now instead of divide, it'll be, so instead of divide, it'll be times. Instead of divide, it's times. And instead of my number or my fraction, it's now its reciprocal. So instead of c over d, now it's d over c. Now the thing to notice here, ladies and gentlemen, is that the first fraction stays the same. When changing division into multiplication, the first fraction stays the same. It's never going to change. It's the second fraction, though. The second fraction becomes its reciprocal. So if I want to change this into a division problem, or excuse me, a multiplication problem, as we just said, the first fraction stays the same. So 1/4 will stay 1/4. We're changing this into a multiplication problem. The second fraction becomes its reciprocal. So instead of 2/3, it'll be 3 halves. I can't reduce anything here, so we multiply. 1 times 3 is 3, and 4 times 2 is 8. 1/4 divided by 2/3 is 3/8. So let's check out 2/3 divided by 1/4. Again, the first fraction stays the same. So this will equal 2/3. We're changing this to multiplication, and then when we do, the second fraction becomes its reciprocal. So 1 over 4 will become 4 over 1. Again, any reducing before multiplying? No, can't do any reducing before multiplying here. So 2 times 4 is 8. 3 times 1 is 3. Now this is an improper fraction, so we do need to go an extra step here and change it into a mixed number. So 3 goes into 8 2 times with 2 left over. Next one, 3/4 divided by 5/7. First fraction always stays the same. Times second fraction becomes its reciprocal. And once again, I can't reduce anything, so 3 times 7 is 21. 4 times 5 is 20. Now that is an improper fraction. 20 goes into 21 once with 1 left over, and remember denominators are stubborn, so it's still going to be 20ths. So 1 and 1/20. All right, well, ladies and gentlemen, I recommend that as we're working through these last few problems that you go ahead and pause the video and see if you can do it yourself, except for this very last one right here and this one that's separate on its own at the bottom. So except for these last two, see if you can give those a shot. Now I'm going to keep doing them, so pause the video if you need to. So here we go. First fraction stays the same. Second fraction becomes its reciprocal, so 4 over 3. Again, no reducing before multiplying here, so I'm just going to go ahead and multiply. 5 times 4 is 20, and 7 times 3 is 21. And so that's a perfectly normal fraction. Circle that. All right, next up, I have 2/15 divided by 6/5. So first fraction equals, first fraction stays the same, times second fraction becomes its reciprocal, so 5/6. So if we multiply these together, 2 times 5 is 10, and 15 times 6, well, we know 15 times 2 is 30, and then times 6 would be 3 more. So 30 times 3 is 90. Well, of course, then we can divide this by 10 over 10, and so this is 1/9. Or, ladies and gentlemen, maybe you noticed with this one that instead we can do a little bit of reducing before multiplying. So my 15 and my 5 can reduce before multiplying. 5 goes into itself once, 5 goes into 15 3 times. 2 and 6 can reduce. 2 goes into itself once, 6 goes into itself, or excuse me, 2 goes into 6 3 times. And then up top I got 1 times 1 is 1, 3 times 3 is 9. So whether we reduce before multiplying or after multiplying, we should end up with the same answer. Now this last one is what's called a complex or compound fraction, and we don't like these. We want to avoid these. These are not okay. So when you run across it, you want to find a way to simplify it. Well, ladies and gentlemen, remember that fractions mean division. And so even though these are fractions within fractions, we can change this into a division problem. Specifically, it'll be the top number, 1/3, divided by the bottom number, 1/2. From here, I can leave the first number alone, change it to times the reciprocal of the second number. And then we multiply. 1 times 2 is 2. 3 times 1 is, not 1. 3 times 1 is 3. This is 2/3. So 1/3 over 1/2 is actually 2/3. And that, ladies and gentlemen, is the end of our lesson.